two rational expressions which we want to multiply. So we simplify each of them first, then we move on to multiplication. The underlying process is still keep factor cancel. It looks like the numerator of the first rational expression has AB in common. If I pull that out, I would have 1 plus 3AB. The denominator, there is nothing I could do about it, so I'll just keep it. So 3A plus 1. The numerator is b squared. In the denominator, I have b cubed and b raised 5. Between the two, b cubed is common. So if I pull b cubed out, I'll have 3 plus b squared. Now we can multiply. Multiply the numerator, a times 1 plus 3ab. There is a b here, and b squared there. That would give me b cubed divided by 3a plus 1, b cubed, 3 plus b squared. B cubed will get cancelled, and there is nothing else that I can cancel, so I'm going to leave the expression as is. So this looks like a very complicated problem, but I don't think so. We could do this easily. So we simplify each rational expression first, then we move on to multiplication. In the first rational expression's numerator, I have a 4a in common. So if I pull 4a out, I am left with 4 minus a. In the denominator, I have an a in common. That would leave me with 16a minus 1. I am going to go ahead and simplify the first rational expression by cancelling out the a's. If you look at the second rational expression, the numerator a squared plus 2ab plus b squared is a special product. And we know that equals to a plus b squared. And in the denominator, we have 4a squared minus 4b squared. So we pull a 4 out. That would leave us with a squared minus b squared. So I'm rewriting or writing the simplified version of the first rational expression. And the second one, I have a plus b squared The denominator is a squared minus b squared, which we know is a special product. So I could write it as a plus b times a minus b. Now I can multiply after I simplify the second rational expression. The a plus b there and there will get cancelled. So I will have 4 over 4 minus a divided by 16a minus 1 times a plus b over 4 times a minus b. The only thing that we can get rid of at this point would be 4. So we have 4 minus a times a plus b divided by 16a minus 1 times a minus b. So we're going to simplify the first rational expression, then simplify the second, then multiply them together. So, oops. A minus 5b. In the denominator, I have an a in common. If I pull that out, I would have a times a plus b multiplied by a plus b times a minus b. In the denominator, excuse me, since we have b squared minus a squared, we have to reverse the order because our special product is a squared minus b squared, which is a plus b times a minus b. Since we have b squared minus a squared, this should be b plus a times b minus a. In the denominator, we have 10b minus 2a. A 2 is in common. If I pull that out, I would have 5b minus a. I can't simplify the first expression, so I'm going to keep it as is. At least not yet. Now I look at the first expression, then move on to the second. I kind of see similar terms. So and you should note that I can delete or cancel a plus b. In the first expression's numerator, we have a minus 5b. In the second expression's denominator, we have 5b minus a. The only thing that we see is that the order is reversed. So I am going to pull a negative 1 out. That would give me a minus 5b. I'm switching the order of the signs, so I simply have to pull a negative out. And now a plus b will get cancelled. A minus 5b will get cancelled. In the numerator, I'm left with b minus a. So if I write it in simple terms, it would be 1 over a multiplied by b minus a divided by negative 1 times 2. So if I pull a negative 1 out of the numerator, I can switch the terms. Divided by a minus 1 times 2. Excuse me, minus 1 times 2. The minuses will get cancelled. So my answer is a minus b divided by 2a. So, going to simplify the first rational expression. So if I pull 2 out, x squared minus 1. If I pull 10 out from the denominator, I'll have x plus 3. There is a 12 in common in the numerator. So if I pull 12 out, I would have x plus 3 divided by 3 times x minus 3. So excuse me, it's not x minus 3, it is x minus 1, because I'm pulling 3 out. So 2 times x plus 1 times x minus 1 divided by 10 times x plus 3. Numerator, 12 times x plus 3 divided by 3 times x minus 1. I can cancel out the x minus 1. I can cancel out the x plus 3. 3 goes into 12 4 times. 2 goes into 10 5 times. So 4 over 5 times x plus 1. That's okay, guys. And so yeah, I kind of figured, because x minus 1, x plus 1 still stayed in the expression. So in this problem, even though that I wrote the first rational expression in a factored form, I did not cancel right away, because I knew that certain terms from the second rational function expression can come into play, or will come into play. But I could have simplified at the very beginning by getting rid of the 2 and the 10 in the first rational expression. I didn't have to wait until the next step. Do we have questions? Okay. Just let me know when you're done. Okay. Before we move on to the next problem, I want to introduce a special product, or two of them, in fact. I did not do this in earlier sessions because I want you guys to get used to the simpler special products first. If we have a cubed plus b cubed, just like we had a case a squared minus b squared, a squared plus b squared is prime, you can't factor that. So if we have a cubed plus b cubed, I can factor it as a plus b times a squared minus ab plus b squared. Always. If you FOIL it, you will see that you'll get a cubed plus b cubed. In a similar manner, if you had a cubed minus b cubed, I can write it as a minus b multiplied by a squared plus b squared. An easier way to remember this is to look at the sign here, and that would be the exact sign for a plus b, or for the first factor, and the second factor or second term in the second factor will have the opposite sign. So here we have negative, there has to be a negative, that becomes positive. So there is a lot going on in this particular rational expression. So what I'm going to do is I'm going to do the first one separately, second one separately, and then multiply them together. So that is the first one. I have a common factor of 2. If I pull that 2 out, I'd have 2 times x cubed minus 8 divided by 6x squared plus 6x minus 36. But I see a 6 in common. So if I pull that out, I would have x squared plus x minus 6. Let's simplify if we can. So 2 and 3. X cubed minus 8 divided by 3 times x squared plus x minus 6. Now, could we factor the numerator? And then we could get to the denominator. X cubed minus 8. You look at that number 8 and ask yourself, well, could I write it as a cube of some number? If you can, then I could use one of the special products. To be very precise, I could use number 2 there. So I'm going to go back and rewrite x cubed minus 8 as x cubed minus 2 cubed. 2 cubed is 8. This would mean a is x and b is 2. I'm going to use the special product. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. It's number 2. And plug in the a and b we identified in this case. So we will have x minus 2, x squared plus a is x, b is 2, 2x plus b squared, which is 4. So we have factored the numerator. Now we want to see if we can factor the denominator. The denominator is x squared plus x minus 6. The 3 doesn't matter, we can leave it as is. I have a 6 or negative 6. I need to come up with 2 factors so that I get that middle coefficient. So if I did positive 3 and negative 2, when I multiply, I am going to get negative 6. When I add, I'm going to get 1, and that's exactly what I'm looking for. So those are my factors that will work. So x squared plus 3x minus 2x minus 6. I have an x in common in the first 2 terms. If I pull that out, I'd have x times x plus 3. I have a negative 2 in common. If I pull that out, I would have negative 2 times x plus 3. X plus 3 is in common now. If I pull that out, I would have x plus 3 times x minus 2. So I factored the first rational expression. The numerator became x minus 2, x squared plus 2x plus 4. And the denominator became x plus 3 times x minus 2. At this moment, I am going to simplify before I proceed. So x minus 2 goes away, x squared plus 2x plus 4 divided by x plus 3. So that is the simplified version of my first rational expression. Now I move on to the second one. 9x plus 18 divided by 3x squared plus 6x plus 12. So numerator, I'm going to pull 9 out. That would give me x plus 2. In the denominator, I have a 3 in common. And that would give me x squared plus 2x plus 4. We have seen that denominator term before. If you go back to our first rational expression, it's sitting in the numerator. Mind you, you cannot factor x squared plus 2x plus 4 in the usual easy way by grouping. Not doable. So let us just simplify before we move on. So 3 goes into 9 3 times, x plus 2 divided by x squared plus 2x plus 4. That is the factored version or the simplified version of the second rational expression. So the first one is x squared plus 2x plus 4 divided by x plus 3. The second one, x plus 2 divided by x squared plus 2x plus 4. Those two would go away. X plus 2 over x plus 3. So we're going to do them separately like we did in the previous problem. So I have x squared minus 3x plus 9, and it looks like I wouldn't be able to factor that directly. So I'm going to keep it as is and move on to the denominator. Right away, I see a 5 in common. So if I pull that 5 out, I'd have x squared minus 4x minus 21. Now I have to factor x squared minus 4x minus 21. Minus 21, I can split it up as negative 7 times positive 3. When I add, I'm going to get negative 4. So I can rewrite negative 4x as negative 7x plus 3x minus 21. There is an x in common in the first two terms. If I pull that out, I would have x minus 7. There is a 3 in common in the last two terms. If I pull that out, I'd have x minus 7. Now I have x minus 7 in common. If I pull that out, I'll leave x plus 3 behind. So the first rational function can be rewritten in this manner because we know the numerator polynomial cannot be factored using grouping. Now we move on to the second one. X squared minus 49 divided by x cubed plus 27. X squared minus 49, I could write it as x squared minus 7 squared, which is of the form a plus b times a minus b. So x plus 7 times x minus 7. The next one is x cubed plus 27. I could write it as x cubed plus 3 cubed. 3 times 3 is 9, 9 times 3 is 27. Anytime you see only two terms, and if one of them is a by x cubed term, the other is a number, the first thing to do is to see if you can write the number as a cube of another number. In this case, I'm able to. So A would be x and B would be 3. We know the special product a cubed plus b cubed is a plus b times a squared minus ab plus b squared. I am going to plug that back in here. A plus b, x plus 3, because a is x, b is 3, x squared minus 3x plus b squared, which is 3 squared, I get 9. So I factored the numerator as x plus 7 times x minus 7 divided by x plus 3 times x squared minus 3x plus 9. Going back to the original expression, I am going to replace the first rational expression by what I simplified, or with what I simplified. So 5 times x minus 7 times x plus 3. The second rational expression, I'm going to rewrite it using the factored form. That term will get cancelled. That term and that term will get cancelled. And that would leave me with x plus 7 in the numerator divided by 5 times x plus 3 times x plus 3 is x plus 3 squared.